Ho ho ho, Merry Christmas! It's always Christmas time whenever we have to use integration by substitution. Anyway, let's zoom right into integration by substitution. This is my favorite integration technique because there's so much behind it. To demonstrate, let's do this question. Find the integral of 2x times x squared plus 4 to the power of 5. I'm gonna zoom in a bit so you can focus on what I'm writing. What I first want to do is substitute this x squared plus 4 with u. So I'll write there let u equals to x squared plus 4. This also means that du over dx will be equals to 2x. And I can also write this as du equals to 2x dx. Now why is this so significant? Why did I let u equals to x squared plus 4? Because this will just become u. And if you look here, 2x dx is actually just du. So these two become du. So actually, this integral just becomes, if you look at x squared plus 4 becomes u. So this becomes u to the power of 5. And then here we are replacing 2x dx with du. And that's it. We'll just get the integral of u to the power of 5 du. And this is now just as simple as using the power rule. This will be 1 over 6 u to the power of 6 plus c. And to finish this question, I'll just write this as 1 over 6 x squared plus 4 plus c. So the whole idea of integration by substitution is to let u equals to something, and then you find du in terms of dx. And you want to choose your u in such a way that the integral becomes very easy to solve, or comparably easier than your original integral. Now, let's go on to our first u sub technique. So earlier what we were performing was a u sub because we're substituting something in terms of x for u. Now for this first u sub, when you see fx and fx plus c, you will sub u equals to fx plus c. We'll see why a bit later. So over here, I have fx and fx plus c. Keep in mind, my fx plus c is just x minus 3. It is not this whole thing, x minus 3 to the power of 6. So let's take u equals to x minus 3. This means that du over dx will be equals to 1. Or du will just be equals to dx. Now our integral will just become, actually what does our integral become? We know that this becomes u, so this is just u to the power of 6. And the dx is just the same as du. I'll write that down first, but we need to replace this x away. Now if we look here, x is just u plus 3. So if we want to write the entire integral in terms of u, this will be u plus 3. Now we want to replace the x in terms of u so that we can do this integral, because this integral is supposed to be entirely in u. And if you look here, instead of doing this very long binomial expansion, we have this very easy rainbow expansion. That's why I will use a u sub for this. So this becomes the integral of u to the power of 7 plus 3u to the power of 6. And this is just 1 over 8 u to the power of 8 plus 3 over 7 u to the power of 7. Don't forget your plus c. And if we replace back the u in terms of x, we get 1 over 8 x minus 3 to the power of 8 plus 3 over 7 x minus 3 to the power of 7 plus c. The next thing I'm going to show you is the second type of u sub. This is when you see fx and some constant multiple of f prime x. This is actually the u sub that we were doing in the first question. We take fx to be x squared plus 4, and f prime x is just 2x, and the 2x is just right here. Why I say constant multiple of f prime x is this doesn't have to be 2x. This can be x, this can be half x, this can be 100x, and this u sub will still work. Now let's look at our first question. Find the integral of arctangent x over 1 plus x squared. Oh no, this looks a bit difficult. But I want you to remember something. The derivative of arctangent x is 1 over 1 plus x squared. So we see fx as arctangent x and f prime x over here and f prime x over here as 1 over 1 plus x squared. So what we want to do is sub u equals to fx. So we sub u equals to arctangent x. And this means that du equals to 1 over 1 plus x squared dx. And if you look over here, this entire part is being replaced by a du. So this becomes as simple as the integral of u du, which is just u squared over 2. Or if I replace it back with x, arctangent x squared over 2. And don't forget your plus c. The next one we're going to do is find the integral of x over square root of 1 minus x squared. Now again, we're trying to find fx and f prime x. Now if you look over here, I actually want to take fx to be equals to 1 minus x squared. F prime x is just negative 2x. That's just a constant multiple of x. You times x by negative 2. That's all. So what we get is fx and a constant multiple of f prime x. So we want to take u equals to 1 minus x squared, which means that du equals to negative 2x dx. Now this x dx over here can just be replaced by du over negative 2. So we'll have our integral as du over negative 2, which is just negative half. And then we have this times 1 over square root u. Again, we're replacing the 1 minus x squared away for u. So we have a square root u in the denominator. Now if we use the power rule, this would be just negative square root u plus c. And replacing this back for x, this is just negative square root 1 minus x squared plus c. Now for our last u sub question, find the integral of tangent x. Now the trick here is I want to represent tangent x in terms of sine x and cosine x. So this just becomes sine x over cosine x. And if you see here, this becomes a very easy u sub, where we have u equals to cosine x, and du will be negative sine x dx. Now if you look over here, if we take u equals to sine x, du will be equals to cosine x dx. Yes. But can we replace this away? No, because cosine x is in the denominator, so we can't replace this away. I know some of you may think this because you may think, oh, sine x is fx and cosine x is f prime x. And if you realize, we can only replace the dx away if we have sine x dx here. And we have sine x dx here because sine x is in your numerator. I just need you to take note of that. So our integral just becomes negative 1 over u. Our cosine x is just u, and sine x dx is actually just negative of du. So this becomes negative ln, remember the mod of u, and then plus c. So this is just negative ln mod cosine x plus c. Now the last special thing we're going to look at is the trig sum. When you see a square root of a squared minus x squared, you will substitute x equals to a sine theta. Now if you see a square root a squared plus x squared, then you will sub x equals to a tangent theta. And finally, if you square root x squared minus a squared, you will substitute x equals to a secant theta. And the reason you want to do this is because you can use trig identities to easily simplify the expression. So let's try out this question. It's not immediately clear if we can use a u sub. So for trig sub, what we want to do is take x equals to sine theta, and we will do dx over d theta equals to cosine theta. So this is just dx equals to cosine theta d theta. So for trig sub, we are replacing the dx in terms of d theta, something in terms of d theta. Okay, let's start. Let's replace everything with theta. So this becomes sine cube theta over square root 1 minus sine square theta. And then we replace dx with cosine theta d theta. Now if you remember your trig identities, sine square theta plus cosine square theta is just equals to 1. So 1 minus sine square theta is just cosine square theta. And if you square root that, this entire thing just becomes cosine theta. So this cosine theta cancels out with this cosine theta. And our integral just becomes sine cube theta d theta. Now what am I going to do? I can make use of the fact that sine square theta is just 1 minus cosine square theta. And what would that do? I can split the sine cube theta into 1 minus cosine square theta and then times another sine theta d theta. And in this way, we can actually perform a u sub. If we let u equals to cosine theta, this means that du equals to negative sine theta d theta. So our integral just becomes 1 minus u square, and then sine theta d theta actually becomes negative du. So we have a du and I'll put a negative outside. I can rewrite this to be u square minus 1 du. So if we do our integration, this becomes 1/3 u to the power of 3 minus u plus c. If I replace away the u, I'll get 1/3 cosine cube theta minus cosine theta plus c. And we still want our integral in terms of x, so theta is actually just sine inverse x. So this is just 1/3 cosine sine inverse x cube minus cosine sine inverse x plus c. Here's a summary sheet for integration by substitution. We have the two different forms of the u sub. When you see an fx and fx plus c, then you sub u equals to fx plus c. And next, when you see an fx and a constant multiple of f prime x, then you sub u equals to fx. Finally, for the trig sub, you have the three versions down below. Usually, u sub has higher priority than trig sub, so if you see something that is more u subbable, then please u sub it before you do trig sub. Also, if you want to challenge yourself, the last integral is actually completely solvable by using u sub. You don't really have to use trig sub for it. But you can try that out on your own. Here are all the questions if you want to look at them again. Thank you so much for watching this video.